Hello, this is the lecture for 9.1, figures in the plane, figures in the plane. Okay, we are going to start with some geometric terms and get familiar with their naming and how we would name those. This is the beginning of the mathematical ideas in geometry, and we make an assumption. We assume that any 2 points determine one and only one line that contains those 2 points. And from this assumption, we build many of our other ideas in geometry. And so a couple of the characteristics about a line goes on forever in both directions. Okay, you will remember that from some of the algebra that you had in the past. The way that you name a line is you just have 2 points on the line, and then you have the arrows on each side of the line. Now, you've got to be sure that you put your arrows there, because if you don't put the arrows there when you name the line, then you're actually talking about a line segment or something else. So be sure when you name your line, you've got your 2 letters as well as your arrows on the end. Now, you can also name it with just a letter. So this can be line L right here. Typically, this is how we look at it, but you do see it sometimes written in this form right here. So, and remember, a line is made up of points. There's infinitely many points on a line, but we look at 2 points on that line to name it. Okay? So now we're going to look. If 3 or more points lie on the same line, we say that those points are collinear. So look at this right here. Here we've got P, Q, and R. P, Q, and R are collinear points because they are all on the same line. Okay, so there's one of the vocabulary words that we're looking at is collinear. If 3 points are not on the same line, they're called non-collinear. And so this example right here, where we've got this triangle, these are non-collinear points, and they intersect. Okay. Now, when we've got a plane, we can have lines that are parallel and lines that intersect. So here we've got lines L and M, and these 2 lines are parallel, and parallel lines never cross. Okay, they never cross. They are parallel. And in this example right here, we've got lines that are intersecting, and this is the point that they are intersecting at point A. Lines P and Q intersect at point A. And our third example is just 3 lines that are parallel to each other. 3 different lines. F, G, and H are all parallel to each other. So these 3 lines right here never cross. They never cross. Okay? Now, a plane is something that's flat. We're only talking about 2 dimensions when we talk about a plane. So a plane is a flat surface, such as a piece of paper or your top of your desk. We will talk about 3 dimensions later on, but right now for this, we're just talking about a plane, and that's a flat surface. Okay. This is examples of what 3 different lines can do. When you have 3 lines in the same plane, all 3 lines can intersect at one point. Okay, these are called concurrent because they all intersect at point B. Okay, our next option is that 2 of the lines are parallel. So 2 lines parallel. Okay, and that's the symbol for parallel. And 1 line intersects both of them. Okay, and that line that intersects both of them is called a transversal. So it's this line right here that's our transversal, and we'll talk a lot about a transversal a little bit later on. Okay, now when all 3 lines intersect at different points, you've got, this is called the general position of three different lines. And we have 3 points of intersection and they form a triangle. But we can also look at how those points in those lines, some of the angles, as we talk about an angle, are congruent, and how we can figure out the measurement of each one of those angles. Okay. Now, a line segment is a part of a line. Okay, so if you had line AB, this line segment AB begins and ends at those points right there. So line segment is part of a line, and they have a stopping point. So this is an end point, and this right here is an end point. Okay, and the way that you name a line segment is you have your 2 letters that are the beginning and the end of your line segment, and then you have a line above it. Now notice when we were naming the line, it would have arrows on each end, but because we're only talking about a line segment, then we just have that straight line on top of it. That's how we would name a line segment. Another geometric figure is the ray. Okay, a ray is a subset of a line. So if we had line PQ, it would look like this. But we're going to have ray PQ. So we are going to start right here. And this is the end point. That right there is the end point. And please notice that when you are naming it, this part right here has to be the part that was on the end point. You could not reverse this and name this QP, because P is this is incorrect right here. You cannot rename it, because the way that this is written, this P is where we have the end point. So we have to have that P first right there. So this would not be allowed. We cannot do it this way right here. That's the incorrect way. Okay. Now, when we have 2 rays that have a common endpoint, that's when we have an angle. Okay, and this angle right here, here is 1 ray that we are looking at. So we have 1 ray here, and then we have another ray right on top of it. And you can have that, and that's a 0 degree angle. Okay, an acute angle is an angle that is less than 90 degrees. So here's some more of those vocabulary words. And a right angle is exactly 90 degrees. Okay, and these are your different angles that you can look at. Now here, we have an obtuse angle that's between 90 degrees and 180 degrees. A straight angle is exactly 180 degrees. Weather team is now available. Okay. And a reflex angle is an angle that's greater than 180 degrees and less than 360 degrees. That's a reflex angle. And you don't look at the reflex angles as often as you look at your obtuse angles and your other angles. Okay, your obtuse, your acute, your straight, all of those. You don't see a reflex angle as much. Okay. Now, 2 angles are congruent. That's another vocabulary word that you want to be familiar with. If they have the exact same measure, so they are the same measurement, then we say that they are congruent angles. Okay, 2 angles are complementary if the sum of their measurements equals 90 degrees. So that would be if I've got this angle right here. Okay, if this was angle 1 and this was angle 2, if the sum of their measurements together equal 90 degrees, then that is called a a complementary angle. A complementary angle. Now, a supplementary angle is when the two angles measure 180 degrees. Okay, so we might have one angle right here and two angles right here. And when you add those two together, you end up with 180 degrees. That is a supplementary angle. Okay. Now, then I know we're talking about lots of vocabulary. Two angles that have a common side and they do not overlap are adjacent angles. Adjacent angles. So here we've got two adjacent angles. Here is angle 1 and here is angle 2. And these are supplementary angles. And supplementary angles mean that their measurement together, so the measurement of angle 1 plus the measurement of angle 2 is going to equal 180 degrees. Okay, now this example right here, angle 3 and 4 are complementary angles. So that means the measure of angle 3 plus the measure of angle 4 is 90 degrees. That's what those mean right there. And this will help us as we are looking at figures and we need to figure out what all the angle measurements are for the figures. Okay. The next angles that we're going to look at, we're going to do an example. Okay, so here is an example, something similar to what you will see on your homework or something that you might see on your quiz. It says, in the figure shown, BXD is a right angle. Now remember, a right angle means 90 degrees. 90 degrees. Okay? Angle AXE is a straight angle, and that's 180 degrees. Okay, now I want you to look right here. Do you see how this says angle BXD? So we've got, here's my point B, and here's my X, and here's my D. I want you to notice that that X right there is the vertex. So when I write this down, I've got the measure of angle BXD. That middle letter right there must be my vertex. That must be my vertex right there. Okay, now I could rewrite that as the measure of angle DXB. That is a completely fine way to write it. But again, that X has got to be my vertex when I rewrite it. So just want to make sure you're clear on how to write those when you're working with these. So we are looking right now at this figure and BXD. So that's this right here. BXD is 90 degrees. Okay, so all of these together is 90 degrees. Okay. AXE is a straight angle. So that means this angle plus these angles all together equal 180 degrees. All four of them added up together. Now, if the measure of BXC, so we're starting right here, BXC, that's what we're looking at right here, the measure of BXC. So the measure of this is 44 degrees. Okay. Determine the measure of AXB, CXD, and DXE without using a protractor. Okay. So what we know right now is we know that this angle, that measure, okay, the measure of angle BXC plus the measure of angle CXD is 90 degrees. Okay, we know that. And we already know that BXC is 44 degrees. So I am able to say that this angle is 44 degrees. And I know that 44 degrees plus CXD is equal to 90 degrees. So by this, I'm able to subtract 90 degrees from, or 44 degrees from 90 degrees to get the measurement of CXD. And so that is going to be that's going to be 46 degrees. So this one right here is 46 degrees. Okay. Now, we are also told that BXE, okay, so this angle right here, BXE, is 149 degrees. So this angle right here is 149 degrees. So let me write that one in a different color. So this whole part right here is 149 degrees. Okay, so what that means is, so let's write the measure of angle CXD is equal to 46 degrees. Okay, so now we've got the measure of angle BXC plus the measure of angle CXD plus the measure of angle DXE. And that is equal to 149 degrees because we are told that right here. Okay, so I'm talking about this angle right here is 149 degrees. Now, we already know, because we're told in the beginning, that BXC is 44 degrees. So we know that that one's 44 degrees. Now, we just figured out that angle CXD is 46 degrees because we subtracted that from 90. CXD is 46. So we know this one's 44 and this one's 46. And so we're able to say plus the measure of DXE is 149 degrees. So the measure of angle DXE is going to be 149 minus 46 minus 44. Okay, so grab your calculator and you are going to do that subtraction. So 149 on your calculator minus 46 minus 44, and you should get 59 degrees. So the measure of angle DXE is going to be 59 degrees. Okay, so I'm going to erase this right now because we've got measurements right here. So we know that this measurement right here is 44 degrees. Okay, and we know that CXD is 46 degrees. And we know that DXE is 59 degrees. Okay, so we have a straight angle right here. So this angle added to the three of these is going to give us 180 degrees. Okay, so we can also look at this angle right here because we know this angle is 149 degrees. So I can say 180 degrees minus 149 degrees is going to be the measurement of AXB. Okay, and so the measurement of AXB is 31 degrees. We need our M right there, measurement of angle AXB. So this is 31 degrees. Okay, and so that's just an example of how we would use this. Okay, so now we're going to talk about vertical angles. And vertical angles are congruent. Okay, so vertical angles right here. Angle 1 and angle 3 are vertical angles, and they're going to have the same measurement. They are congruent. And then I have angle 2 and angle 4, and they are going to have the same measurement, and they are also congruent. So if we are given the measurement of one of those angles, and that's just two intersecting lines, okay, we are able to determine the other four. Now, something that you also need to remember is this is a straight line right here. Okay, that's a straight line right there. So what that means is the measurement of angle 1 plus the measurement of angle 2 is going to be 180 degrees. Okay, the same is true for angles 2 and 3 because they form a line. Okay, angles 3 and 4 form a line, and angles 4 and 1 form a line. So we can also use that information to determine the measurements of angles. Okay, now let's talk about the transversal, and you might remember this from high school. And so what we're looking at when we're talking about this transversal, we're talking about a figure that looks like this. You've got two parallel lines right here. These are parallel, and you have to be told that they're parallel. So lines L and M are parallel. And this line right here is the transversal. Okay, that's the transversal. So what we're looking at, if two parallel lines are cut by a transversal, then the corresponding angles have the same measurement. Okay, so we already know about vertical angles. Now we're going to talk about corresponding angles have the same measurement. If two lines in the plane are cut by a transversal and some pair of corresponding angles has the same measure, then the lines are parallel. Okay, so we're kind of talking about the same thing here. It's just a reverse. One is you're told that the lines are parallel, and you can determine what their corresponding angles are. The other is if you have corresponding angles, then you can determine that the two lines are parallel. So let's look at this right here. So when we're talking about corresponding angles, what you're thinking about is you're talking about this area right here, these angles. Okay, if I take these angles and I pick them up and I put them right on top of these angles, those are called corresponding angles. So your corresponding angles here, 1 and 5 are corresponding angles. Okay, 2 and 6 are corresponding angles. 3 and 7 are corresponding angles. And 4 and 8 are corresponding angles. Okay, so that means their measurements are the same. The measurements are the same. So what we're going to do is we're going to use vertical angles and corresponding angles and supplementary, which are two angles that equal 180 degrees, to determine all of the other measures of this figure right here, this geometric parallel lines. So we are told that this angle right here is 35 degrees. Okay, now we know that angle 6 is corresponding to angle 2. They are corresponding angles, so this angle right here is going to be 35 degrees. Now, angle 6 and angle 8 are vertical angles, so they are also going to be 35 degrees. Okay, so 6 and 8 are vertical angles. 2 and 4 are vertical angles, so this is also going to be 35 degrees. Now, we've got to determine what the other angles are. So what we're going to do is we're going to look at this line right here. This is a line. And so what we know is that the measure of angle 6 plus the measure of angle 7 is going to be 180 degrees. Okay, we know that because they form a straight line. So measure of angle 6 is 35 degrees. So then I can figure out the measure of angle 7 by subtracting 35 degrees. So the measure of angle 7 is going to be 145 degrees. So this angle is 145 degrees. And if angle 7 is 145 degrees, then angle 5 also has to be 145 degrees because they are vertical angles. We also know that angle 7 and angle 3 are corresponding angles, so they are going to have the same measurement. And then 1 and 3 are vertical, so they are going to have the same measurement. Okay, so that is finding the angles using vertical and corresponding. Now, based on what we just did, we can also talk about alternate interior angles. So an alternate interior angle is angle 3 and angle 5. Those are alternate interior angles. Another set of alternate interior angles are 4 and 6, and those are called alternate interior angles. You can also have alternate exterior angles, and these are alternate exterior angles as well as 1 and 7. And alternate interior and alternate exterior angles all have, and let me do that in a different color. There we go, just to make sure we've got them straight. Alternate interior angles and alternate exterior angles all have the same measurement. They all have the same measurement. Okay. And these are your alternate interior angles that we just talked about on the last screen. Alternate interior. Okay. Now, here we've got the sum of the measures of the angles in a triangle are 180 degrees. And that is probably something that you remember from high school geometry. Okay, that's definitely something you will also be teaching in elementary school. The sum of the measure of the angles in a triangle is 180 degrees. What I also want you to see is this line right here is parallel to this line in our triangle. Okay, so these two angles are going to be alternate interior angles, and these two angles are going to be alternate interior angles. So if we've got a straight line right here in our triangle that's parallel to this one right here, we are able to determine the measure of these angles. Okay, and we are going to do some of these right now.